Currently, we are in an art studio. And here in our art studio, we are going to build our first simple linear regression model. As you can see it here that we have set up a working directory. And in our working directory, we have a one CSV file having our data. And the name of that CSV file is clinical_dataset.csv. We have already loaded that dataset in our R Studio, as you can see here in the environment. There are 100 observations and the 10 variables. In a lot of previous practical tutorials, we have explained to you that what does it mean by the variables and what does it mean by the observations. We hope so that this concept will not be confusing for you. Let's check the structure of our dataset by using the str function. We will type the str and then we will write down the name of the variable that is holding our data. And as you know that the name of our variable is data. After typing this, we will run this piece of code by hitting the run button or pressing the Control Enter key. And once we will do that, then look at the console. We will have the structure of our dataset. In this structure of the dataset, you can see the numeric variables and as well as the categorical variables. There are the two numeric variables in which right now we are interested. The first one is an age and the second one is an heart rate. And we want to see that is there any impact of the age on the heart rate? To find out a quantitative relationship between them, what we are going to do, we are going to build a simple linear regression model between these two numeric variables. We hope so that by looking at the age and the heart rate numeric variables, you can understand it well that the age is going to be our independent variable while the heart rate is going to be our dependent variable. Please keep it into mind that biologically the heart rate is dependent upon the age. Might be you know it that when you are the young, then your heart rate is normally high. And as you're getting old, your heart rate is getting down. And as you're getting old, your heart rate will be lower. To build a simple linear regression model, first we are going to create a variable and let's set the name of the variable is a model. After typing the name of the variable, we will give a sign of equality, and after giving a sign of equality, we will use the function that will build the simple linear regression model for us. In the previous video tutorial, we have explained it to you that what will be that function. This function will be the lm function, and this function belongs to the stats package, which is an R-based package. After typing the lm, we will give the parentheses. And after giving the parentheses, now first we will type the name of our dependent variable. And in our case, the dependent variable is heart rate. So we will type heart rate. After typing the heart rate, we will give the tilted sign. This is actually going to be the tilted sign. Now, after typing the tilted sign, now you will type the name of your independent variable. And the name of our independent variable is age. After typing the name of independent variable, we will give a comma, and after giving a comma, we will type the data argument. After typing the data argument, we will give the sign of equality, and after giving a sign of equality, we will write down the name of the variable that is holding our data. And in our case, the name of the variable that is holding our data is data. After typing this, now we will come out of the parentheses and we will run this piece of code. When you will run this piece of code and you will find out no error message, it means that your regression model is built. As you can see it here, look at the environment tab. In the environment tab, you can see a model has been built with a list of 12. What does it mean? We will talk about it later on. Now we want to see the values which are associated with our model. To see the values which are associated with our model, we will type the summary function. After typing the summary, we will give the parentheses and we will type the name of the variable that is holding our regression model. And name of the variable that is holding our regression model is model. After typing this, we will run this piece of code. And when we will run this piece of code, then look at the console. In the console, you will have all of the values which are associated with your simple linear regression model. And the first value will be the residual. Here, you are going to have a residual in form of interquartile range, as you can see it here. The minimum value of the residual in your model is minus 18.5582. while the maximum value of the residual in your model is 25.7600. Between the minimum and the maximum, you can see the first quartile, the median value, and the third quartile. Below the residual, you can see the coefficients, and there are the two coefficients which are particularly very important for us. The first one is going to be the intercept, and the second one is going to be the age. We will talk about the intercept and the age a bit later in the next video tutorial. After having an idea about the intercept and the age, now look at the R-square value of your model. The R-square value of your model is 0.004172. And obviously, this is not pretty good. It means that our model is not going to explain all of the variations of our data. We hope so that now these things will be clear to you. Along with these values, you can see a lot of other values, including the F-statistics, the standard errors, the t-value, the PR, and etc. etc. These are some advanced concepts, and we will talk about them in a hypothesis testing module of our course. Now, after building the model, let's visualize our model. And to visualize our model, we will use the ggplot library. So let's call the ggplot library by typing the function library. And after library, we will type the ggplot2. Let's run this piece of code. When we will run this piece of code, then the ggplot library will be activated, and now this is available for us to visualize our model. To visualize our model, we will type first the ggplot, and then we will type the name of the variable that is holding our data. And the name of the variable is data. This is the data layer of the ggplot. After typing this, we will move to the next layer of the ggplot, and that is going to be the static layer. And we will type AES to define this layer. After typing AES, we will give the parentheses, and we will define X and the Y variable. As you know that on the X-axis, there should be independent variable, and on a Y-axis, there should be the dependent variable. And that's why we will type X, and then put the age on the X-axis, and heart rate on the Y-axis. After defining the second layer of the ggplot, which is a static layer, now we will move to the geometry layer. We will come out of the parentheses and we will give a plus sign, and now we will define the geometry of our plot. We want to build the scatter plot. To build the scatter plot, we will type the geom_point. After defining the geometry layer, now we will define the stats method that we want to apply on our plot. Now, to apply the stats method, we will give a plus sign, and then we will type geom_smooth. And after typing the geom_smooth, we will move inside the parentheses. And inside the parentheses, we will type our method. And our method is going to be the linear regression. So we will type the method. And after typing the method, we will give a sign of equality. And after giving a sign of equality, we will give the comma inverted comma. And within the comma inverted comma, we will type LM. We have already explained it to you that what does it mean by the LM? The LM stands for the linear regression model. We can also define the color of our regression line by giving a comma, and the call is equal to red. Now our code is ready for execution. After typing this piece of code, let's run it. When you will run this piece of code, then you can see the regression line in a scatter plot. This regression line is the best fit line. We hope so that now this concept will be clear to you, and you can build the regression model by yourself and also visualize the regression models by using the ggplot. Please stay with us. In the next video tutorial, we will explain the interpretation of all of these values that you got in an output of your regression model.